Today we will discuss more about prime numbers. So the discussion is the numbers of prime numbers. Is it infinite or finite? We can recognize prime and composite number with their factors. Here 23 has only two factors, that's 1 and 23. But 25 has more than two factors. So 23 is prime and 25 is a composite number. By this way we will find 3, 5, 7, 11, 13 and so on, all our prime numbers. Does it has end or it's endless? Let's find out. Now see, there are numbers of prime numbers in between 1 to 1000 is 168, 1000 to 2000 is 135, 2000 to 3000 is 127 and 3000 to 4000 is 120. It is also seen that the numbers get bigger and longer, prime numbers become scarce and less frequent. It may come to your mind that how many prime numbers are there? Up to August 21, when I am making this video, the largest known prime number is 2 to the power 82,589,933 minus 1. Oh, such a big number, which has 24,862,048 digits. Can you imagine that? If you're going to write down this number, it would be longer than the entire text of Harry Potter series. If you think that this is the last prime number or the last prime number can be found in future, then you are highly wrong. In 300 BC, greatest Greek mathematician Euclid proved that the prime numbers are infinite. Why not we understand this theorem with an easy example? Let's assume that 7 be the last prime number. So 2, 3, 5, 7 be the set of all prime numbers. Let's locate all the prime numbers on the number line. Let's imagine that n is just greater than the multiplication of 2, 3, 5 and 7, which we know 211. This number must be greater than 7. So, what would be the factors of 211? Definitely it would not be 2, 3, 5, 7 because there is always a remainder which is 1. So, it has no factors in the set of all prime numbers. So, 211 may be prime, may be composite. If it is prime, then it is the new prime number which is bigger than the 7, and if it is composite, then it must have a prime factor in between 7 and 211. In both cases, we got a new prime number. In this way, we will find more and more prime numbers. Now, let's understand the actual proof. Let's assume that there are finite numbers of prime numbers and the last prime number is p. Let's look at all the prime numbers on the number line. Further, think that n be the number which is product of all prime numbers plus 1. So this number must be greater than p. Now what will be the factors of n? Will it be 2, 3, 5, 7 or p? Definitely not. When you try to divide n with any prime number, it always has a remainder 1. So, it has no factors in the set of all prime numbers. We can say that n may be prime or may not be prime. If n be a prime number, then a new prime number is found, which is n. And if n is not a prime number, then n must have a prime factor in between p and n. In both cases, we got a new prime number, which is greater than our assumed last prime number p. In this way, we'll find more and more prime numbers, which proves that there are infinitely many prime numbers. If you have any query about this episode, you can write down in the comment section. Thanks for watching.